Hi everyone, you're welcome to this tutorial session. Today we want to solve this Maths Olympiad question. Root A plus root B is equal to 10 and root AB is also equal to 10. What are the values of the real numbers A and B? Okay, so please watch from the beginning to the end because a lot of explanation will be given for every important step that we will have to take in this solution of the solution of this Maths Olympiad question. Okay, let's start. Root A plus root B is 10 and root AB is also 10. To find the values of A and B. A and B are real numbers. How do we go about that? Now, let us first of all look. First of all, we know square root of negative numbers do not exist in the set of real number line. Alright, so it therefore means that A and B must all be positive. Another proof is that the square root of A plus square root of B gives us a positive whole number. Okay, even the square root of the product also gives us a positive whole number. It therefore means that A must be positive, B must also be positive. Okay, with that analysis done, let's transform this equation in a manner such that we can use the applications of the relations between the roots and coefficients of a quadratic equation. Because if we see up here, we see the sum and then we see the product. Okay, so let's transform this. Okay, if we call this one equation 1, we call this equation 1. This other one, square root of AB can be written as square root of A multiplied to square root of B. So that we can actually see the product. We can call this equation 2. So we can see that equation 1 is actually the sum and equation 2 is the product. So if we let say capital X be root A and capital Y to be root B, then equation 1 and equation 2 will become, we'll now have X plus Y is equal to 10 as our equation 1, and then X, Y, 10 as our equation 2. Okay, so we can see sum and we can see product. Now we are assuming, so we want to use the quadratic relation. Okay, on its roots. We are using this because this have the same nature as any quadratic equation. Okay, so the general quadratic equation that we know in terms of x will be x squared minus sum of roots multiplied to x plus product of roots is equal to 0. Okay, where here our sum of roots, we want to keep capital X and capital Y as our roots. Our sum of roots is x plus y, which is 10, and our product of roots is the product xy, which is also 10. Okay, so here we want to treat capital X and capital Y as the roots of this quadratic equation that we want to form, since we can see sum of root, product of roots. So let's consider capital X and capital Y as the roots of the new quadratic equation that we want to form. So we want to make use of this important information from quadratics. All right, so what equation then do we obtain? Let's form out the equation in terms of small x. No confusion here, this is small x, and we want to look for big X, the capital X. All right, so we're going to have equation becomes x squared minus sum of root is 10 multiplied to small x plus product of root, which is 10, is equal to 0. So this is a quadratic equation that we have to come up, that we have to solve. Okay, this quadratic equation was derived from our knowledge of this information that we have. We're transforming this question into a quadratic so as to facilitate our solution. Okay, so we have to solve for the roots of this quadratic equation. all the two values of x that we get here, they will be valid for x and they will also be valid for y. Okay, so let's solve for x and the two values of x. X is equal to minus b plus minus the root of b squared minus 4ac all over 2a. Okay, so if we collect our information very well, a is the coefficient of x squared term. The coefficient is 1. So and b is the coefficient of x term, which is negative 10. So we're going to have negative 10 plus minus the square root of b squared is negative 10 squared minus 4. A is 1 and our c is 10. Okay, all of that divided by 2a. So this gives us negative is plus positive. So we have 10 plus minus the square root of negative 10 squared is 100 minus 4 times 10 is 40 all over 2. Okay, now this gives us 10 plus minus the root of 100 minus 40 is 60 all over 2, which is 10 plus minus. We look for a square number, which is a factor of 60. Okay, remember a square number is a number whose square root is also a whole number. So which factor of 60 is a square number? Is 4. 60 is the same as 4 times 15. So this square root of 60 is the same as square root of 4 times 15. Now, from the laws of search, it becomes square root of 4 multiplied to square root of 15. Square root of 4 is 2. So we have 10 plus minus 2 root 15 all over 2. Now 2 is common at the numerator and the denominator. So we simplify it to 10 divided by 2, 5. 2 divided by 2 is 1. So the values of small x are 5 plus minus root 15. Those are the two roots of that quadratic equation that we formed. Those are the two roots. And these two roots, they are valid for both capital X and capital Y. They are valid for both capital X and capital Y. Okay. So we have found the values of capital X and capital Y. So let's write them down. So we are saying capital X is either 5 plus root 15 or 5 minus root 15. Capital Y also is either 5 plus root 15 or 5 minus root 15. Those are the values of capital X and capital Y. But look at our question. Our question did not ask us to solve for capital X, capital Y. There's no capital X or capital Y in our original question. Our original question is in terms of A and B. So what is the value of A? What is the value of B? We remember that capital X was the root of A. Okay, capital X is the root of A. So when capital X is 5 plus root 15, so we are saying that what? We are saying this therefore means that root of A is either 5 plus root 15 or 5 minus root 15. Now this implies, okay, if we square both sides, this implies A is equal to 5 plus root 15 squared. This also implies A will be 5 minus root 15, all of that squared. Okay, so these are the two possible values of A. Now, what about Y? Y will also be the same thing. All right. Also, we're told that capital Y Now we did the substitution, capital Y for root B. Okay, so this therefore means that root B will either be equal to 5 plus root 15 or 5 minus root 15. Okay, so what is B? We have to square both sides to get B. This automatically implies that B will be what? Will be 5 plus root 15 squared or 5 minus root 15 squared. Okay, so we're getting the values of A and B. It will be very nice if we verify. So let's verify. Verify to see if our solution is correct. Let's verify. Okay, look at our equations up there. Root A plus root B equals 10. All right. These are the possible values of root A. These are the possible values of root A, and these are the possible values of root B. So if we take root A plus root B, that will give us, if we take this, we're going to have 5 plus root 15. Then plus our root B. Our root B will be 5 minus root 15. You see, if we add them up together, we're going to have 5 plus 5, which is 10, root 15 minus root 15, which is 0. All right, so that gives us, pay attention here, it was supposed to be 5 minus root B, 5 plus root B. Sorry for that mix up. Okay, all right, so we have seen that the first verification holds. Second verification, the products root A, root B will be equal to 5 plus root 15 into 5 minus root 15. Okay, when we multiply that out, we get 5 multiplied to 5, 25. All right, 5 multiplied to negative root 15, 5 root 15. 5 multiplied to positive root 15, 5 root 15, then negative 15. So we obtain this one here is 0, 25 minus 15, 10. So again, we have the product agree. The left hand side agrees with the right hand side. So this simply concludes that the solutions that we got for A and B are correct.